lapse rates, an atmospheric physics experiment. Okay, so why does temperature decrease with altitude? Temperature decreases with altitude because light travels from the sun in the form of ultraviolet waves, and they hit the ground and they bounce back as infrared waves, which is heat. So the area closest to the ground is heated the most. Another reason why temperature decreases with altitude is because the air molecules are denser toward the ground, so they can retain more heat than the thinner air at higher altitudes. The troposphere is the lowest layer of the Earth's atmosphere. It contains 75% of the atmosphere's mass and 99% of its water vapor and aerosols, and it also contains all of the Earth's weather.
One method of describing the troposphere is called the atmospheric lapse rate, which is defined as the decrease in an atmospheric variable, usually temperature, with an increase in height. One variation is called a dry lapse rate, where the air has less than 100% humidity, and so the lapse rate is -3 times 10 to the -3rd degrees Celsius per foot. Using this lapse rate, we are able to calculate temperature at any given altitude using the equation. Final temperature is equal to the initial temperature minus lapse rate times height. What we want to prove is that our rocket board thermometer is capable of measuring a lapse rate equal to that standard lapse rate.
We built our rocket using an Aerotech Aero Kit with a nose cone, body tube, fins, and a motor. At the top of its flight, the top body tube comes out and the parachute deploys. We wrapped our thermometer and altimeter in a paper towel and put it in this body tube. We used RockSim 9 flight simulation to predict the height of our flight. And on July 25th, we had 3 launches at Fiesta Island using a thermometer and an altimeter.
From our actual rocket. So the purpose of our first launch was to calculate the apogees so that we could predict the apogees and temperature differentials for the next 2 flights. As you can see, our predicted apogees were this one. However, our actual temperatures were significantly greater than our predicted temperatures, meaning that our lapse rates were significantly smaller than the actual lapse rate. In fact, our lapse rates were -4 times 10 to the -4th degrees Celsius per foot, and -5 times 10 to the 10 times to the -5th degrees Celsius per foot. And as I stated earlier, the standard lapse rate is -3 times 10 to the -3rd degrees Celsius per foot.
And as you can see from our charts, our temperature decreased at a pretty much steady rate, however not at the lapse rate that we had expected.
Even though our lapse rate numbers were wrong, they mirrored an actual lapse rate in that they decreased as a linear function.
Okay, there were 2 sources of human error. One was that the thermometer was insulated inside of a paper towel in one of the body tubes of the rocket, and so it didn't have enough ventilation to allow the pressure to equalize. Another source of human error was that we only had 2 launches, and so we didn't have enough accurate data as we should have.
Our results are important in that they mirror a small portion of the experiments done in the Earth's atmosphere. If we were to conduct more rocket soundings, we would fix the design of our rocket so that our placement of the thermometer would be conducive to accurate temperature readings. Accurate rocket soundings will help us understand the nature of the Earth's climate and the behavior of our atmosphere. Thank you.
Thank you. Thank you. Questions?
How high did your rocket go?
The highest was 1,492 feet. Or that was predicted. 194 feet.
Do you know how fast it went?
We didn't measure.
Thank you.